Looks like we're live. Hello everyone and welcome to yet another Azosian session. Today is an Azosian session. Let's make a little bit of an announcement and officially start the stream. So, let's wait until Discord recomputes its layout as usual, so it will take a little bit of time. I don't know, my laptop is rather slow. So, live on Twitch. I'm actually considering to just start using something like the alternative Discord client. I forgot the name of it. Right, so what are we doing today? On Twitch.television? Today we're developing a search engine in Rust. Holy fucking shit. That sounds actually very epic. I really like that title. That's a very good title. That's a very strong title, I would say. So essentially, what's the idea for today's stream? I've been browsing the documentation for the OpenGL lately. I think it's called docsgl, and I noticed some cringe in this website, like a little bit of a cringe. And the cringe is essentially you can only search by the names of the freaking functions. By the names of the freaking functions. You can't really search by the descriptions of those functions, for instance, and that's kind of fucking cringe, right? So look how much text you have in here. Look how much shit you have in here. You can search by all of that stuff. And so I decided, hey, some time ago, I did a pretty interesting project, which is called, which was related to XKCD. I do remember that. It was related to XKCD. Let me actually find that. XKCD. Oh, XKCD indicer. So, the idea of this project is rather simple. Basically, download all of the metadata from XKCD. So there is a XKCD JSON.html, which basically explains the API of XKCD. You can actually download all of the metadata and whatnot, and it gives you alternative text of the XKCD, the usual thing that you have in there, and also some sort of description or maybe some metadata. I don't quite remember. I think. Yeah, it has a title and alternative text, yeah. So, and essentially, it basically indexes all of that data and puts it into SQL database. And then from that SQL database, you can basically search for certain XKCDs from the keywords. Right. So, and the model that we used to index the XKCD was called, I think, TF-IDF. Right. So basically the term frequency inverse document frequency. Right. It's actually a very simple model. I'm not really sure if it's called model, but the very simple idea. Right. So the idea is the following. Right. So basically you have a set of documents. And a document is a set of terms. In our case, it could be like a set of words. So the term frequency is basically how a certain term, aka word, how frequently it occurs in that specific document. Right. This is a term frequency. Right. So if you put a bunch of terms in search, it can take. You can take your term and see how frequently that term occurs in each of the document, and you can basically sort the documents by that specific term. But on top of the term frequency, there is IDF, inverse document frequency, and this is a very interesting idea. All right, so essentially, you may have a term that is very frequent in all of the documents. It is very high frequency in all of the documents. So that may occur if we're talking about terms like A, right? So the article A, right? It's a term that is going to be very frequent in all of the documents, right? So an inverse document frequency essentially says the following thing, right? The value, the rating of a certain term is how frequent it is in that document divided by how frequent it is in other documents. You see what I mean? Right, so essentially you have a very frequent term that occurs in a document, but if the same term occurs very frequently in other documents, it's probably noise, so you want to kind of exclude it. Right, so this is basically what ADF sort of solves. Right, so and what you have at the end is the term frequency inverse document frequency. Term frequency gives you how frequently it is in the document, and IDF tells you whether it's noise or not. Right. So I used this model for this entire thing, but I don't remember if I use IDF here. I remember that I wanted to use a TF-IDF, and I think I ended up using only TF, which is kind of weird, but this thing worked really well. And we even integrated it in our bot some time ago, right? So it's not in the current version of the bot. Maybe I should actually port that to the bot as well. But yeah, so, and what I decided to do, I decided to basically refresh my knowledge of this thing and just implement the same idea for the docs.gl. And it's like rather easy because you have the entire website on GitHub, right? So you can just grab it from the GitHub. And furthermore, on the GitHub, it is in a form that is easy to parse, right? So you have all of the sections in here which contain XHTMLs. So basically, as far as I know, it comes with some scripts that pre-process the XHTMLs and turn it into a proper website. What we can do, we can just basically take these documents and basically index them with TF-IDF directly without any pre-processing and stuff like that. And essentially what we can do, right, so we have some sort of XML in here, we can just strip off all of the tags and leave only the text nodes. And in the text nodes, we can just use TF-IDF. And then we'll be able to search using this sort of technique on all of the documents, right? So maybe you want to search for some sort of like you know, some operation on a texture, right? So you'll describe it in sort of a sentence. We're going to split it into the terms. Then we're going to look up the TF-IDF in the indexed documents and range the documents how likely you're searching for that specific function or something like that. And to maybe refresh my knowledge of Rust, I decided to do that in Rust, right? So that's basically the idea. And as soon as I get this kind of like a simple utility, I may extend it, right? So I may actually make it work with more than XMLs, maybe with also text files, maybe also JSON files, maybe HTML files. You can make it work with HTML files, and then you can write a crawler that collects the HTMLs on the internet. You can plug these two things together and you got your simple search engine. By the way, as far as I know, like early versions of Google, like very early versions of Google, were basically using that. If I remember correctly, I'm not 100% sure, but I think the early versions of Google were basically using that. And so though the Google had a very interesting revolutionary idea, the idea was to actually give a feedback from the user. So essentially, the way the documents were sorted was not affected only by the terms, but also by how often users clicked on certain documents on certain websites. So essentially, if the user clicked on a certain website, in a ranking, it would give it more priority just because other users click on it. And because of that, Google at the beginning felt like it knew what you want because other people clicked on it, so you're more likely to actually click on that as well. So right now, Google works completely differently, right? So it actually works worse. It's kind of funny. Have you guys noticed that Google, like today, is kind of like worse than it was in the past? I wonder if you take the old version of Google, would it feel better than the current version? Maybe this shit is actually better. Maybe that's the reason why Google was better, actually. Maybe that's what you want, but I don't know, it's kind of weird. So maybe the problem, right, today, like a lot of websites, they use shit ton of JavaScript, and because of that, it's kind of more difficult to index those websites, and that's why Google and other search engines are so shit, right? Because there's not that many websites left that you can just index, or I don't know. So yeah, that's basically the idea of today's stream. So I can see a lot of subs all of a sudden. Right, so let me take a look. Oh boy, where's my soy? I need a lot of soy to actually read all of that. So, okay. Apocryphos subscribed for 13 months. Thank you so much. Have you considered writing Google in Rust? This is precisely what I'm doing today. That's right. So maybe I'm going to make it a little bit bigger. Marcia Ven Neto, thank you so much for 5 months. Jia Yang, thank you so much for 43 months. Holy shit, look at that. 43 months. It's insane. PogChamp, PogChamp, indeed. Matt Kruger, thank you so much for 3 months. Says, hey, hello. Limis XH, thank you so much for 7 months. Hello, Mr. Tsoding, hello. I hope you're having a great day. I'm having actually a pretty great day. So this is more of like an evening right now. Ken Rand, thank you so much for 9-month resubscription. Xarist, thank you so much for 11 months. We're back to back. Champions of the arena. Neil KM, thank you so much for 100 bits. Thank you. That's a lot of subs all of a sudden, right? So I guess I know what I have to do. I just have to not stream for a week. So, and when I go back, people start subbing like crazy, thinking that I'm gone, but I'm not actually gone. So, yeah, that's gonna be the idea for today. So we can just, go ahead, grab some data, and implement like a simple indexer that also will allow us to search within that index, right? And if we come up with something interesting, we can start extending it. Maybe we're gonna add some sort of a web interface. Maybe we're gonna store the index in a database, and slowly but steadily you may actually get some sort of a search engine. Or maybe this project is gonna end on this stream. Who knows? Maybe it's gonna be fucking boring. We'll see. That's the beauty of the Zuzin session. So I think I want to give the links to the different stuff. So here is a TF-IDF. Right, for anyone who's interested, I'm gonna also copy paste it in the chat. Right, so this is that, and here is the XKCD indexer that I implemented some time ago, right? So it's here. If anyone is interested, and indexer, and also the source code of docs.jl. So this is what we're doing. All right, so let's create a folder with a project. So how are we gonna call this search engine, right? So let me think about the name. Let me think about the name for the search engine. Search engine in Rust. Yeah, let's replace this thing with SE. Rust. Yeah. Let's call it Cirrust. I really like this name, Cirrust. Cirrust. So I'm gonna create Cirrust, and I don't remember how to use cargo, so it's gonna be something like cargo init. I think that's how we do that, and there we go. We initialize that shite. So the reason why I usually don't like to use like build tools, and especially cargo, even though I program in Rust, right? So, but today we're going to probably be using some sort of like a third-party dependencies, because one of the things we'll need to do, we'll need to parse XMLs, right? And to be able to parse XMLs, I don't want to implement the XML parser right now. It sounds like a fun idea, probably. I don't know, maybe not, considering the XML standard, but I don't want to do it today. Okay. So we have a hello world. Let's actually try to run this entire shit. So this is going to be cargo run. So is it going to say hello world? It's saying hello world. Would you look at that? Isn't that amazing? So the first thing I want to probably do, I want to basically clone the docs.jl website. Right. So let's actually clone it. I hope it's not very big. 359 commits, so it's not that big, but it may take some time. Don't want to wait, honestly. So you know what I'm gonna do? I'm going to actually set up a depth, because you can clone not all of the commits, you can clone a certain depth. I think you can say depth 1, right? And it will effectively clone like the last commit, and it's gonna be super quick. You're not gonna have an access to the whole history, right? But you don't really need to, right? So in our case, we are not interested in the history of the project. We're more interested in the data that we can have in here. So let's actually pick a certain file and start experimenting with that specific file. So something maybe like GL clear. Right, so this is a GL clear, and let's take this thing. So boom, go to src, and let's say that the file with which we're going to be working right now is going to be glclear xhtml, right? So the first thing I probably want to do, I probably want to read that file. So we've got a bit more subs, so let me actually read them out. So Saucy Time, thank you so much for Twitch Prime subscription. Cheriso Tofu, thank you so much for 8 months. Full bar bus with the message full bar bus, thank you so much. Alundra Braga, thank you so much for tier 1 subscription. Sodin Whip indeed. And Pakel1, thank you so much for tier 1 subscription, 10 months. Thank you. Really appreciate all of the subs, even though I don't get the money, but I really appreciate the gesture. You know what I mean? I really appreciate the gesture. Okay, so how do you even read files in Rust? I don't remember. But I remember that you can do rust up doc, and it will just do a magical thing. It will give you Rust documentation. You can search for extensive API, and you got a local version of the Rust API, which is kind of cool, right? So I remember that there was a package, something like stdfs, and within the stdfs, you could read some stuff. Read to, I think it was to string, yeah, read to string. So you can like read the entire thing. And that's pretty poggers, my dudes, right? So let's actually use stdfs, right? So fs, read to string. So we're going to do file path, and then we can say content, right? So this entire thing, of course, returns the results. So we have to check if like no error has occurred, right? So let's actually put some sort of garbage in here to trigger an error just to see how it's going to go. So you know what I like about a result? I kind of like the method in result, which is called unwrap or else. I think that's how it's called. Yeah. So unwrap or else. So essentially it tries to unwrap the value, but if it couldn't unwrap it, it allows you to handle that situation so you can provide like some sort of a closure. And that way, I like to actually handle it similarly to how I handle errors in C, right? Unwrap or else, right? And here I've got an error, and I usually like to report it in a very specific format. I like the format that I report errors in, so the usual style, C style report, right? So just error, and then you say could not read file path because of this reason, right? Maybe file doesn't exist, and then I like to exit like you know, exit syscall and exit with like non-zero exit code. This is what I like to do. I know this is not traditional, right? I know this is not traditional in Rust community, but this is my project. I like to do things my way. Right. So it's kind of funny how programming in Rust feels like running like a you know, food channel. You have to always say that this is not traditional, but this is just like how I like to do that, right? So if you don't say that, people is gonna like fucking downvote you and stuff like that. All right, so we want to do process, and we're going to do exit or something like this. Right. So we got the content. So the thing I probably want to do, I want to print the content and just see what's inside of that file. So let's do cargo run. And what do we have in here? So we forgot a semicolon. Okay, so as you can see, it says could not read file, no such file or directory. So, and this is the style of like errors that I like. This is like a usual classical C style, and just like, yeah. Anyway, so as you can see, there was an error, but if we change this entire thing, there will be no error. And here is the stuff. Here is the stuff, which is rather convenient. So this entire thing, if I remember correctly, right? If I remember correctly, so we probably want to go to here. It returns you literally a string. Right, we can say something like size of file path is, maybe let's put it this way, length of file path is length. And here's a cool thing that I recently learned in Rust is that in println you can do just length equal content length, right? And it will just like print you like that. So it will basically use here whatever expression you put in here, but since it's named, you can actually put that in any order that you want. And file path is taken from the current scope, right? So it's kind of an interesting way of doing the string interpolation. So this is the length of the file. This is the length of the file. So as you can see, we're capable of reading files, which is kind of cool. So the thing I want to do now, I want to be able to parse the XML, right? So to parse the XML. So let me take a look. As far as I know, in crates.io, right before the stream, I just looked up what are the common XML parsing libraries, and I think we want to use xml.rs because that's the thing that all of the other XML libraries use. Right, all of the other libraries are just basically wrappers around this thing, and this is like a pure parser that is written in Rust with the minimum dependencies, and this is what I like to use. I don't like to use too many transitive dependencies that wrap around different frameworks, right? So Surdy XML RS is basically like a glue between a serialization framework and XML parser, And I don't need a serialization framework. I just want to parse a little bit of XML, right? So why do I need this additional glue? So I'm not going to use that. This one is actually really nice, right? So it's like a very minimal amount of dependencies. It depends on libc for some reason, as far as I know. It doesn't really depend on anything. So there's only dev dependencies. Oh, there's like 0 dependencies basically. Yeah. So which is kind of cool, right? So this is what we're going to use. So you can add it, I suppose, to cargo like this. You can just say cargo add, and it will automatically add this entire thing, hopefully. I should have not actually used this way of doing this. So if you do shell command in Emacs like that, it actually blocks Emacs until the command is actually finished. And if there is any sort of a progress right now, we can't see that at all. I can try to like do something like this and just try to do it like that, and now it's updated. Oh, that's why it couldn't. Yeah, so you can't just add a dependency. You need to update the index, right? You can't just add things. All right, so I think we've got a bunch of subs yet again. So let me see. Omega Sad Life, thank you so much for 6 months of tier 1, and Composicum, I hope I pronounced your nickname correctly. Thank you so much for tier 1 sub. Alrighty, so we're updating the indices, right? So I guess if you're watching on YouTube, I'm probably gonna cut this because there's nothing much to say. So So how's it going, everyone? How's it going, everyone? The YouTube people cannot hear us, so you can tell me everything that you don't want the YouTube people to hear. Oh, look, it's adding the dependencies. Okay, don't tell me, we're already done. All right, so it finally added it. It really didn't took that much time. So let me see. Okay, so here's the dependency, which is nice. Cargo build. All right, so I don't remember, can you do just like doc and create documentation? Yeah, so for XML-RS, and to be able to use that documentation, can you just ask doc to open the browser, just like rust up? Oh yeah, you can do that, actually, that's very cool. Open. Is it gonna open it in the browser? I don't see shit. Is it opening it? It couldn't open that. So I would expect this thing to use something like xdg open, right? Which automatically like detects what kind of browser you're using, but it couldn't really open it for some reason. So I can open it myself, like at least it printed the thing. Right, okay, so here we have XML. And I would like to see some stuff. If I remember correctly, this thing is a sax parser, right? So sax. So do you guys know what is a sax parser? Sax parser. Why is it in Russian? I should switch the language. Like, why does it keep giving me in this weird language that I don't speak anyway? So simple API for XML. So essentially, usually when you think about like parsing certain format, you're thinking about, I'm going to give you a string and you're going to give me AST. And then I traverse that AST myself. So the sax parser for XML is not that. It is not that. It is event-based. So essentially, it doesn't build any AST, but it traverses the XML. And every time it encounters, for example, an opened tag or a closed tag or text node, it basically calls your callback. You provide a bunch of callbacks for the things that you're interested in, and the parser is going to call those callbacks for you, right? And if you don't really need to, to parse the entire XML tree, and you just want to extract some information, this is actually ideal. And this is precisely what we want to do. I don't really care about the structure of the XML, right? So the document that I'm looking at, right, it has some sort of a structure, but I don't give a shit about it, honestly. So probably have to do docs. What is that? GL4, GL clear, XHTML. So the only thing is I'm interested in is this stuff. right? The text nodes, the actual text nodes. I want to extract those. So if I can put some sort of a callback when you encounter a text node, and then I'm going to take all of the text that I encounter and append it to the buffer, and there you go, I have a text that I can actually index with TF-IDF. Right, so then I can split it into the terms, then I can count the frequencies of these terms and put them in some sort of a database that I can then use to compute TF-IDF. Right, so that's basically the idea. Right, and what's cool is that we can implement it in the future generic enough that maybe we'll support more formats. Right, again, so right now we're supporting XML, but who said we can't support just text? Supporting text is going to be easy, just to read the entire text without parsing it. Then we can try to support PDF. Who knows, maybe we'll find like a library that allows us to extract text from PDF, and then you'll be able to index PDFs. Right, and then HTML, right? So, and maybe like I kind of like this idea. I kind of wanted to have something like that for quite some time. So basically I would take my folder where I store different documentation that I downloaded from the internet. I quite often, by the way, download documentation from the internet locally to have it locally, because I have these interesting offline sessions when I want to work on something, and to get rid of all of the possible distractions, I basically turn off the internet completely. Like I imagine that I have a computer, so it's some sort of like a post-apocalyptic scenario. We don't have an access to the internet, but I have my laptop left, and whatever I have on that laptop, only that I'm allowed to use. Right, and because of that, it actually creates a very interesting effect. I can focus on what I need to do. And because I don't have an access to the internet, it actually forces me to think more creatively when I'm trying to solve problems. You know what's interesting? Right, so essentially I'm working on a project that uses certain dependencies, certain libraries, right? Before going offline, I'm downloading the source code of all of the dependencies that I have and the documentation for all of the dependencies that I have. Right, and because I don't have an internet, I'm kind of forced to read documentation, right, to understand what's going on. And quite often I'm also forced to read the source code of the dependencies. So this kind of thing forces me to actually start reading the source code of the libraries, and I actually gained more insights into how libraries works and how to do things without those libraries, thus simplifying my projects. Right, so, and again, you can't really force yourself to do that unless you like physically don't have an access to the internet and stuff like that. It sounds weird, it sounds very inefficient. We're living in a very sort of like efficiency-driven world. That's why we develop ChatGPT and stuff like that. But by doing that, I actually learned a lot, and I gained a lot of interesting insights. And it kind of like, in some sense, it's kind of therapeutic. You know what I mean? It's like you cut off yourself from the outside world, and all of a sudden, like all of the noise that is coming from the internet, it just like shuts off, and you just like postpone for a second, and you just like enjoy the moment, right? Without all of the noise from the internet that is constantly driving you to be more efficient, develop faster. Let's just like shut the fuck up, just, and you get some time to think, to ponder upon the thing, even though it's not that efficient. But nobody's actually driving you to be super efficient, because you cut off all of these voices that's coming from this goddamn Ethernet cable. You know what I'm talking about? Right. And because of that, like I have a folder with the documentation, and if I have a tool that can index that documentation, I can have my own local Google. Isn't that cool? Right? I can have my own little Google that works kind of like an old version of Google with TF-IDF and stuff like that. It could search by XMLs, by HTMLs, by PDFs and stuff like that. So I have like a bunch of also computer science white papers that are in PDF. So why not search in them like that? So that sounds like a pretty cool idea. Like yeah, you have like a bunch of stuff in a folder. You can say index that folder and search in that folder like Google. And since you don't really have the amount of data of the whole internet, you don't need the infrastructure of Google. You can be Google on a smaller scale. Can shut off voices of the internet, but can't shut off the voices in my head. Relatable, truly relatable. And okay. Anyway. So yeah, that's basically the stuff that I wanted to get out of my system, right? So, because I don't know, I'm not that old, but I remember the times when the internet was much less noisy than it is right now. And it was like, and you could actually have a productive and meaningful conversations on the internet. Right now, go to any social network, it's just like people screaming at each other without even listening to each other. That's what's weird. Like you look at like two people on the internet or on Twitter arguing with each other. You read what they say, you try to understand their arguments, and you can clearly see that they don't listen to each other arguments, they're just yelling at each other for no apparent reason. It's just like so weird to me. That's what internet turned into, just people yelling at each other. Right, so... Anyways, I'm sorry. Alright, so let's go and let's try to parse some XMLs. Let's try to parse some XMLs, bruv. Okay, so we'll probably need to have some reader. Yeah, reader. Event reader. Would you look at that? We have event reader. And I can create event reader from something that is called source, and source is something readable. So you can create like a read interface. And you know what implements the read interface? A file. Right, so if you take a look at the file, so I think it's located somewhere in the FS, yeah. So if we take a look at the file, and what kind of interfaces does it implement? It should implement the read interfaces. Is there a list of the interfaces? Yeah, there we go. So you can open a file and it implements the read interface. So that means I can feed that file into the event reader. Right, and then I can start pulling off. Oh, so does this thing implement? It also implements an iterator. Okay, event reader accepts something that is readable, and by itself it is an iterator, so we can iterate through the XML events. Right, so and here, yeah, XML events is one of those things. Right, so we can try to do that. Though you can convert it into iterator, right? So it's not really iterator by itself, but you can convert it into iterator. So, and how do you convert it into iterator? I don't remember what's the methods. Why are you redirecting me to this website? Okay. So into iter, right? So that's what you have to do. Okay, that's cool. Alrighty. So can I just use XML? Right. So we'll just try to use the XML. And this is not what I wanted. I just wanted to build. Yeah, I can't do that. Isn't that pores? So, and essentially what we can do, we can do XML. Oh, you have to do something like, okay, reader, event reader. So event reader, new, and might as well also include file, right? So file, open this thing. So, but when I open the file, does that operation fail? Well, it can fail, right? So that means you can't just open, but this thing also doesn't accept a result, right? So that means we can actually just like use something like this. We can take this entire thing and put it in here, right? It looks like shit, by the way, so maybe it will be better to actually have something like this in here, right? Could not open file, blah blah blah, and then you can just put the file in here, and you have event reader, and the event reader is just like, yeah, so it's called ER, so this is the event reader, and here I can do something like into iter. Right, and try to just print this entire thing. But I'm pretty sure you can't display an event, but you can probably debug this thing. Right. Okay, so let's try to build it and see. Okay, so it's actually correct code. Let's try to run this entire thing. And we got all of the events. This is actually very easy. What the fuck? Right, so yeah. So for example, when an element starts, you get an event start element. When something ends, you get end element. And I think what we care about, right, so for example, I saw the copyright or something. Copyright, yeah, there we go. Not really copyright, but... Okay, characters. I think that's the event that we care about. We just care about the characters. You know what I mean? We just care about the characters. So maybe because of that, right, I'm going to only filter those. So interestingly, is there anything? I'm thinking like a Haskell programmer right now, because I feel like I want to have a sequence, you know, in Haskell there is a sequence which essentially accepts like the list of applicative or monads or something like that and returns you the applicative of list, right, something like that. So, but I think I actually proven to myself that programming like that is not particularly efficient, so I'm not going to do that. Right, so essentially if event, we can actually try to unwrap this entire thing, or even unwrap or else. So, and I can do it like that. So as far as I know, in Rust, it is actually very common to shadow bindings, right? So because that's what it is common to do in OCaml, right? So for instance, you have a binding event and you shadow it in here, replacing it, and it's totally fine in Rust as far as I know, right? It is totally fine in Rust as far as I know. Okay, so I'm just like looking at some stuff. Unfortunately, Twitch doesn't really have a feature that would tell me that I already acknowledged some of these people. So in some of the other services like Streamlabs or Stream Elements, you can click on people. I don't want to report the person, but yeah, you can click indicating that, okay, I already acknowledged that person, but you can't do that on Twitch. Right. So Twitch doesn't even understand the need of its users. How unusual, who would have expected, right? Right, so error could not read next XML event, right? Notingnaso, I'm not sure how to pronounce your nickname, Notingnaso. Thank you so much for Twitch Prime with the message sub. Hello, welcome to yet another Azuzin session. I'm sorry for speaking like that. Alright, so in here we're gonna just exit instantly. Right. So here's an event, and the thing that I care about, I only kind of care about the character event, right? If the characters, so let's put it like this, text, if let characters text event, right, we're going to print that specific text, right? So, but here is an interesting thing, the characters, right? So characters, what's the parameter for that thing? So here's the characters, and it's a string, it's literally a string, so that means I can just like literally print it like that. All right. So let's go, characters not found in the scope, and this is because it is available in the reader. So I probably need to go and import XML event, right? So this is going to be XML event. And also I have to put XML event in here. Right. So here's the XML event. A poggers, isn't that poggers? I think it's, yeah, there we go. So we have a text. We basically have a text. All right, so maybe we can collect that text into some sort of a buffer. It's not really particularly interesting text. But there are some descriptions in here, right? So, yeah, so there is a description, sets the bit plane, blah, blah, blah. So some parameters in here. If you're searching for one of these parameters, so this document may appear in the results, right? So these things are kind of important and stuff like that. So, yeah. So what we can do in here, we can actually build some sort of a buffer, right? So this is basically buffer. Let's call it content. String new. And what we want to do in here, we kind of want to append this thing to the string. But the question is, string, does it have something like? Can I append? Thing you can extend. How can you extend? You can extend with an iterator, so you can push str. This is actually perfect, right? So content push str, and I can probably just, you know, do it like that. There we go. And we can just print the content. So, and the cool thing here is that now I can wrap that into some sort of a function, and it will return me the content of that XML file, right? So the content of the XML file that I'm really interested in, right? So this, of course, content has to be mutable, sure, because this is Rust. It's being anal like that, but that's fine. That's just Rust. Okay, so that's cool. That's pretty cool, actually. So there's also some sort of like, yeah, how is that called? Like a template parameters and whatnot. Mirila 0BR or OBR, thank you so much for tier 1 subscription. Thank you, thank you, thank you. I'm not sure if I acknowledge you or not, but yeah. Thank you, thank you, thank you. All right, so let me see. Okay, that's cool. So let's create some sort of a function, right? So read entire XML file, right? So in here I'm going to do file path, and then I'm going to say, okay, Emacs, what are you doing? Give me the entire shit, right? So essentially, can I just do something like IO result, and this is going to be a string. So, and then what I can do, I can use another function on a higher level that finds all of the XML files, and then I can call this function on each individual XML file and get the content of all of the files, right? So that's basically how abstracting away things works. I'm not quite sure why I'm not using file path in here, right? So that's a very simple mistake. Right, and essentially I want to move this entire stuff to here, and here is OK content. Right, and what's cool now is that I'm inside of a function that returns the result, which means I can just do something like this, right? So I can start like using this question mark notation, which allows me to sort of like unwrap things very easily. Furthermore, this allows me to inline this entire thing, thus simplifying this stuff dramatically. Right, so as you can see now, it's a very simple function, right? So the content is basically read entire XML file. So this is a file path. So for now, I can just unwrap it. Right, but yeah, there we go. So we don't use nexit, but we're gonna use it soon. Oh yeah, there is some incompatible errors and stuff like that. You can't easily do that. So, and this is because the error is yeah, the trait from error is not implemented, and the error is supposed, yeah, okay. So the way you're supposed to sort of solve that, if I remember correctly, you create an error that encapsulates both IO error and XML reader error, right? And basically implement like a from XML error that converts it into your more abstract error, and also from IO error that converts you to abstract error or something like that. So that's how we usually solve that. Right, but for now I'm not really sure if I really care about that, so it's gonna be unwrap to do. So in this one is to do. So I think it's expect, right? Yeah, it's expect, and this one is also expect. This one is also expect, and there you go. So what I want to do now, instead of having like a file path, I want to have a dir path. All right, so I want to have a dir path, and I want to take a look at all of the files within that directory, right? So how can we do that? If I remember correctly, so fs has something like a read directory. Does it have a read dir? It does have a read dir. I do remember that correctly. Holy shit. So you can provide the file and you get a read dir, which is an iterator, right? So it is an iterator, and the element of the iterator is a dir entry. It is a dir entry, and dir entry, it has a path associated with it. It has some metadata, so you can have a metadata about the stuff. You can have file type, right? So this is very convenient. So you have a function that you can say, okay, read the directory. It's an iterator. You can iterate through each individual file of the directory. So tron mtg subscribed with Twitch Prime saying that C is better than Rust, and I could not agree with that more. I could not agree with that more. I really like C. I actually like C more than Rust. Even though Rust fixes the safety problems of C, it is not even near to simplicity of C. And for some reason in the modern world, nobody asks the question, can you have a safe language without sacrificing the simplicity? And the problem is that it's kind of difficult to answer that question because simplicity for a majority of people is kind of like different, right? And on top of that, usually like these kind of like Rust languages attract very smart, very enthusiastic individuals. And the problem with very smart, young, enthusiastic individuals is that they're very easily nerd sniped. They're very easily nerd sniped. So if you don't know what is a nerd sniping, Google it up. So it's an XKCD joke, but it actually describes it very accurately. And because of that, they're spending too much time on very complicated, interesting, but not important things. You know what I mean? So essentially, Rust right now is a sandbox for very smart people to build interesting toys to play with, right? So they build like a lot of interesting abstractions on top of abstractions, on top of abstractions, frameworks and stuff like that, and you're gluing together package managers, all of that, like the consoles and stuff like that. But where's the actual work? Where's the freaking actual work? Yeah, so we need a safe language, but also the one that doesn't try to, that cares about simplicity as well. I know that things come at a cost, right? So if you want a more secure language, you have to pay maybe with simplicity a bit. But it's just like, in case of a Rust, the simplicity is just like thrown out of the window completely. Like just fuck that, security is the most. Like simplicity, we're not gonna even try to optimize these two variables. It's just like we're gonna pick one and make absolutely miserable language, but safe. Safe, right? Just let's try to balance between these things. Like, come on, Jesus. Anyway, but it's not really possible with the current situation. So it is what it is. C++ is complicated and unsafe. Yeah, exactly. So it's the worst of both worlds. Anyway. So I guess it's kind of like more a psychological problem, right? So when people work with simple languages, right, they don't feel like they're doing something important. Maybe that's the problem, right? So for instance, take Go. Go is a very simple language, right, on purpose, and quite often less experienced developers, when they program in Go, they feel like they're being like a small cogwheels in a huge corporate machine, right? Which is kind of understandable, right? So people want to feel important, people want to feel special. But in reality, I don't know. Okay, so we got the, holy shit, we got 10 gifted subs from Dear Bear Zero. Thank you so much for 10 gifted subs, really appreciate that. So I suppose my Rust rant works. I should rant about Rust more. All right. So let's actually read the directory. How do you even freaking read the directory? I completely forgot. Yeah, you have to do the usual fs read dir path. Dir path. I wonder if I can just like do something like io result. And yeah, since I'm streaming, maybe I'm not gonna spend too much time on errors and whatnot. Okay, so read dir. Oh, I remember. I think you can do something like this, which means that it will also import fs. So then you can just like use fs in here, which is kind of interesting, right? So, okay, so there was a bunch of warnings, but one of the things I want to do, it like this. So, dir, so we're gonna call it dir, right? So we've got the dir. And then what we want to do, we want to iterate files in dir, right? And let's just print those files in the directory, right? So this is going to be a file, and let's see what we've got. And here are the files. It's as simple as that. Look at that. Look how easy it is to just read a folder. Isn't that bow? Isn't that bow? I think it's pretty fucking bow. Yeah, and we'll have to index all of this shit. Okay, right, so then if I want to do something like file equal file, so since it's okay, right, since it's okay, we can also do something like maybe file, so question mark, and dir entry. Let me find the dir entry. Where is the dir entry? A fan path, yeah, that's what I wanted to have. I wanted to have a fan path, but the fan path is a path buffer. It is a path buffer, so you can't, yeah, you can only print it with like with the debug stuff. You can only print it like that, and there we go. So we have the strings, which we can then path through this entire stuff, right? We can path through read entire XML file. There we go. File, path, read entire, right? So we can have a content, and we can say something like, so let's call it like this. File path is basically file path in here. So then we read that, and then we can do the following thing. So file path, and let's print the size of each individual file path. And the size is basically the content length, right? So essentially we can iterate through each individual files, and we can compute their lengths. File path. So expected str, but found this thing. So as far as I know, like quite often, the functions do the following thing. Read to string. They don't really accept the string, but they accept something that is convertible to path. Yeah, as ref path, blah, 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 blah. We can kind of try to do a similar thing, but it's like, the thing about Rust that I don't like, it just adds additional noise, right? It adds additional noise for you to think about. Right, so here's the file path. Let's give it a try. And also, I'll probably have to find the path some way here, so it's going to be a use std path path, right? So you'll have to do it like that, and let's take a look at the errors. So this is a content length, and the content is an error, so we probably want to do something like this. Yeah. What's the next error? Since it's that, we have to display it properly, but here I can just do this stuff. Okay, what's the next error? Path was moved. Okay, so that means I want to actually borrow it by this, and there we go. Look at that. Look how it's slow. Look how it's slow. It's lagging a little bit. It's not like instant. That means the program is doing some work. That means the program is doing some work. I mean, well, why slow? People asking why slow. Because it's parsing XML. It's parsing XML. It's like actually doing work. It's not CAD. It's not just text files. You have to parse XML and just compute things around. Just, you know. So that means it's serious. That means it's important. You know, there was an interesting thing when the computers were only introduced into people's workflow, right? People had a huge problem with trusting the computers because they were working too fast, right? They were working too fast. Like they couldn't believe that you can do this complicated intellectual work so freaking fast. It must be making mistakes. it must be making mistakes. And because of that, for some time, developers on purpose put like sleeps in the software to make it slow because people didn't trust it enough. Right. So it's the same. You see, it's slow. It's doing something, right? So you can trust the result of this program, right? Like otherwise, like, why would it spend so much time? Well, I mean, I heard about that on a level of rumors. Maybe it's just like a, made up story, but this is something that I was told by other more experienced developers in the past. So, well, I mean, it sounds plausible enough. Let's put it this way. It sounds plausible enough. Well, I mean, on our Discord server, somebody recently posted a video about how if you make your interface slower, you get a better UI UX, which is basically the same idea, isn't it? Right. Do you remember that? Somebody posted that on our Discord server recently, right? So basically make your interface slower, and you will increase the usability because it's too fast. I can't comprehend what's going on or something like that. Yeah, it's basically the same idea, isn't it? Anyways, but maybe another thing. Maybe this is because we're not running in release mode. So let's actually try to run, but in release. So it's gonna take some time to compile in release because you need to apply some optimization. Yep. No, it's still rather slow, so that means it's actually doing some important work. It is actually doing some important work. Okay. Anyway. So, what I'm thinking is actually slightly faster, just a tiny bit faster. Yes. The next thing we need to do. Okay, so we can already quite easily start introducing the following things. So std collections, hash map, right? So, and essentially, for each individual file, you can build a function. Let's put it this way. Let's call it index for now, but maybe I'm going to change its name a little bit like later. So the content, right, we accept the content, which is going to be str, but what we want to get a hash map of a single word or a single term and its frequency, like how frequently does this entire shit happen, right? And implement it. Index document, right? Doc content. And I'm going to put underscore in here, right? So, oh, I think, yeah, there's something like this, but I mean to do that's the trick as well. Okay, so you index document, and then we can build a bigger hash map, right? So we can then build a bigger hash map, right? So I'm not sure how to call this thing, but all documents. Which is essentially hash map from the path, right? So we can call it something like path and whatnot. From the path to the document to the frequency of the words within that document, right? So within that document, string usize. And this is basically sort of like the final index we're looking for, right? This is the final index we're looking to build. So you have a hash map from a path to a file, to a frequency of individual terms within that file, within that document. Right, so something like that. And maybe we'll be able to save this entire thing in the file system. I was thinking, if the indexing is going to be fast enough, maybe we never have to actually save it because we can just basically reindex everything every time we want to search something. But looking at the current performance of the application, I think it makes sense to actually save this hash map somewhere. Right, so, and this is just a single folder, by the way, chat, look, this is just a single folder. We have several of them, Right, so this is one folder. Right, we have also GL3, right? We have GL2, we have embedded stuff and stuff like that, right? And I wonder if this is because of the XML. Maybe the XML parser is so slow, right? Because, yeah, that's what it feels like. It feels like XML parser. Maybe with the text file, it would do that differently. So, yeah, it would be also kind of cool if the final system that we built, you could give it any file and it tries to detect what kind of file it is, maybe by extension for now, like TXT, XML, HTML, PDF, and depending on the type of the file, it would use different parsers for this specific document. You know what I mean? That would be kind of cool. That's pretty pogers, my dude. These are pogers. Things pretty fucking pogers. So yeah. So we need to index document. But here's an interesting thing, right? So the technique generally is talking about the frequency of the terms. But the question, what is a term? Right, let's take a look at one of the existing documents, right? So let me grab the compilation, GL clear. Maybe I'm gonna just grab this thing. And I'm gonna read entire XML file in here. Right, so we're reading entire XML file, like so. And then I unwrap this entire stuff, and then I'm gonna say, okay, print the content of this thing, like so. Boom. And let's comment out everything else, everything that we don't really care about. I don't think we need that stuff anymore. Well, I mean, this is literally what I was doing in here. Okay, sure. Okay, and let's just try to run the entire thing. Should have probably not used the release because it doesn't really matter. Right. So what is the term? Because you can split everything by spaces, right? You can split everything by spaces. But then you have words that contain commas. They contain commas. And what if we have the same word zero somewhere without the comma? Is it going to be considered like a different name, or like this one with the dot or something like that? How do we handle these additional noisy characters, that punctuation characters and something like that? How do we handle them? One of the way we can handle them is basically filtering them out. But this entire thing kind of feels like, it feels a little bit familiar, don't you think? The problem of figuring out what is individual element of the text, right? So what is the individual element of the text? Is it things that's separated by spaces, or within the characters also there is some sort of additional meaning that actually tells us that this is not a single term, but actually two of them? You know what I mean? Right. So space is not the only thing. It's not the only thing that tells us the differences between the borders between the terms. There's also the terms themselves, right? We can treat dot as a different term. So this sounds like tokenization. Not only tokenization, but the actual tokenization that is used in programming languages. It's literally the same problem. And you know what's funny? I never realized that until yesterday, until I got the idea for today's stream. I never realized that this is the same problem that we solve in programming languages, like literally the same problem, and you can use the same freaking code. And it's kind of weird, like how didn't I realize that? And it actually makes everything so easy, right? So you split it into tokens the same way you tokenize a programming language, and a single token becomes the term. And since comma and dot are terms that are encountered in documents so frequently, the TF-IDF is gonna filter it out as noise automatically. You don't even have to think about that. This is so cool. Think about that, right? So because the comma and dot are gonna be the terms that occurs very frequently within the documents. So the system, the formula automatically filters it out as a noise. That is freaking perfect. This is so cool. Don't you think? Chat, is that freaking power? Freaking power. Okay, so let me take a look. So thank you so much for additional sub from MTG. Yeah, I already addressed that. Dear0, thank you so much for oh yeah, already said that. Things falling apart. Thank you so much for the Twitch Prime and stuff like that. So you know what I'm gonna do? I'm gonna actually select this thing, and this is gonna be an indicator that like where I last acknowledged people. 5 heads. Who needs to ask Twitch to implement features when you can use built-in features of the browser? You can just mark, okay, so this is the last person I acknowledge, so we're gonna have more. And you know what's funny? Probably in before, adding new element to that list will actually clean up the selections. Maybe not, we'll see. You have to subscribe. Subscribe so we can see if it actually removes the selection. Okay, anyway. Debate. So we need to implement the tokenizer. We need to implement the thing that, given a string, will actually, you know, split all of that into tokens. But we're gonna get into that before a small break because I need to make a cup of tea. Okay, good. So let's write a tokenizer, right? So literally the tokenizer that I usually write when I need to tokenize some shit in a programming language, right? So let's go. We're gonna have a structure, a Lexer, right? And what I like to keep in a Lexer is the content of the thing that I'm currently parsing, right? So maybe it's gonna be something like a string, and then maybe I'm going to keep some sort of a cursor, but here's an interesting thing, right? So I don't really want the Lexer to own the content that is currently parsing, right? Because it's not going to really modify that content, right? So it would be totally fine if it just like borrowed it, right? But because I'm storing the reference inside of the structure, that means I need to explicitly tell the lifetime of this thing, which I usually don't like to do. But let's just go for it, right? So let's just go for it and see how it goes. Right, so on top of that, I kind of want to also support the Unicode, right? So maybe because of that, I'm going to actually parse characters instead of a string, right? So specific characters. That may require to, when we read the document and we sort of parse everything, like converting it into characters, and maybe that's fine. And since this is a slice, right? So this is a slice. Slice stores two things. It stores the pointer at the beginning of the memory where data, you know, starts, and the size of the amount of elements that you have in a slice. Because of that, maybe the cursor itself is not really that important because it's already kind of contained within the content. So essentially, if we consume a bunch of characters, we can just like reslice the content and move on. Right, so the content itself already kind of contains the cursor, if you know what I mean, right? So, yeah, let's go. Let's implement the rest of the stuff. So this is going to be Lexer. Let's implement the constructor for this entire stuff. Let's implement the constructor. All right, so Defense, thank you so much. I already acknowledge you. And Brooklyn Dev, thank you so much for Twitch Prime. Thank you. I really appreciate that. Alrighty, so how are we going to be constructing all that? I suppose we're going to be just accepting the thing, right? We're going to accepting the slice, and we're going to return self, I suppose. I think this is going to be just self, and this is just self content, actually. So this is going to be just content. All right. So what we're going to do? I think I'm going to take the content. I'm going to take the content that we have in here. So this is the content. And let's convert this entire thing to a character. So I think this is how we're going to be doing characters, and then collect all of that into a vector. Right, so this is going to be a vector. So we store this entire thing into a vector. So content is going to be the thing that owns the character that we read from the file. Right, so it owns that. And then we're going to create the Lexer we're going to create the Lexer that borrows that thing, right? So that borrows that thing, and there we go, we got a Lexer. And let's actually try to print the Lexer just to see what's going on, but we can't really print that, right? So it has to be a debug. So I just want to see what's going on in here. So this is the debug, and let's go. Okay. So what do we have in here? So we have to put comma in here. Let's go. And yeah, so here is the Lexer. So this is the output. So this is the entire content. And as you can see, these are the characters. It's so slow because of Emacs, but here are the characters. We can clearly see that. So yeah, it works. Cool. So the next thing I want to do, I want to have a function that takes the next token, right? So next token. We're going to take the mutable self, right? Because as we consume the tokens, we're going to be reslicing the content and reassigning it back to this field. So that means we have to be like mutable. So in here, what we're going to return, we can literally just return that slice, right? So essentially, Lexer is just a reslicer. That's why it doesn't really own this character, because what it does, it takes your slice that you own, just looks at it and gives you like sub-slices. It doesn't need to own anything, so that's why it doesn't need to move inside of it. It can just like look from the distance at the data that you get, if that makes any sense, right? All right. So, and essentially how I usually develop the Lexers, I trim the white spaces from the left, right? So trim the white spaces from the left. How are we going to be trimming the white spaces from the left? Well, so while the content is greater than 0, that means we have something in the content, and if that something is a white space, that means we need to get rid of that character. So we keep get rid of the characters until we have no more white spaces, right? So essentially what we can do, we can take the content, right? It's a slice. We can reslice it. We can say, okay, take from the 1 up until the end. So that effectively kind of remove the first character, right? So, and then you basically reassign it back to the content. As far as now, you also have to take the, I don't remember, I think the compiler will tell me, right? So, and this is what we're doing here, right? So this is how we can trim all of the white spaces from the left. While we have something to trim, we're going to be doing that. All right, so we'll get some errors, and yeah, so the type is character. You have to actually take the pointer to this thing, and there we go. Yeah. So let's maybe put that to a separate function. Trim left, going to be mutable self. And every time you need to trim the white spaces, you just call this thing trim left. And here's an interesting thing, right? If after trimming all of the white spaces, you end up with a thing that is empty, well, you ran out of the tokens, right? So there's nothing to tokenize. You may want to return like an empty token, or maybe to indicate that we reach the end, we can return option in here. Right, and simply return none in here, and that will allow us to turn the Lexer into iterator, right? Because so this is a toolchain. So iterator. If you take a look at the iterator interface, I'm calling them interfaces, so they're usually called traits, but this is actually an interface, right? An iterator is something that has a method next, and next returns optional item. If we say that the Lexer is an item of slices of characters, we can actually adapt it to the iterator interface, right? And treat it as an iterator. So let me actually try to run this entire thing. As you can see, it compiles, and we can say, okay, implement iterator for Lexer, right? So the compiler will tell us what we have to implement in here. Right, so it tells that I need to specify the item. What's going to be the item? So I think this is called associated type, right? So we're going to say that the associated type in here is the slice, right? And then we need to implement the next. So it accepts mutable self, and it should return option of self item, right? So this is how we're going to be doing that. And I'm going to just basically proxy that call to the next token, right? So So I'm gonna be proxying there, and that's it. So that essentially means that I can treat the Lexer as an iterator. So that means I can do something like token in, and then I can just print the tokens like so. Isn't that cool? Isn't that cool? I think it's pretty freaking cool, mate. So yeah, it's an iterator. I think I already done that before. Yeah. So this is not the first Lexer that I implemented in Rust. So this is like a very natural thing to do in Rust, to turn Lexer into an iterator. So yeah, let's try to compile this. And as you can see, we don't really have anything, right? We don't really have anything. So which means that we probably need to implement some top tier commentary from Todding, right? Okay, so I suppose the first thing we want to do, we want to start lexing the words, right? So, and the word starts with alpha, right? Alpha numeric, maybe. It depends on whether we want to treat numbers and words separately. I think we want to treat them kind of separately. I think it makes sense. Yeah, for the purpose of searching, it does make sense. I'm going to tokenize words and numbers similarly to how we do that in programming languages, meaning that if you have thousandth, this is two separate tokens. But if you have your mom 69 for 20, this is a single token, like so, right? This is how we do that in programming languages, but maybe it's not a particularly great idea. We'll see. So you can always change this entire thing, but I'm gonna do it like that for now. So if self content, so we know that content has at least something. That means we can do something like this. If content is I don't remember, alphabetic, okay, is alphabetic, right? So what we need to do, we need to keep consuming until it's alphabetic, right? So let's actually have some sort of like an index, right? While n is less than self-content length and self-content n, by the way, I think I forgot to put something behind my camera. There we go. Yep. While this thing is alpha numeric, right, we keep incrementing this thing, right? And now, as soon as we reach the end of the content or the end of alphanumeric things, we need to chop off that token. So we need to take content starting from 0 up until n, right? So n is usually not included. So this is the token that we'll need to return. But before we can return that, we need to also remove it from the Lexer. So what we have to do, we have to reslice it. So we need to do content starting from n up until the end, right? So, and that's the new content that we're reassigning here. And then we just return some result, right? We might as well actually call it token. I think that makes sense, right? So this is the token. Cool. All right. So what we have? So let me take a look at the errors. So the token. Oh, yeah. So we need to take the reference in here. So what's the rest of the stuff? This thing has to be mutable, of course, because it's Rust. Okay, so the first thing we got is this name. So name GL, it's kind of difficult to read, so let me actually change it. So as far as I know, so this is the sequence of characters. So that means I can turn it into iterator, then collect it into a string, right? So that's what I can do. I can collect it into a string. Never used. Yeah, there we go. So name GL. Really, is that really what we've got? Yeah, I see. So this is because when we read XML, we actually read the chunks of text and we append them without any separation. So that means some words from one XML chunk can get blended in with other words from another chunk. And that may result with these weird tokens. So this is very dangerous, actually. This is very dangerous. So what we have to do when we are reading from the XML, we have to pad this stuff a little bit, right? So essentially we're going to do content, and after that we can push just a space, because the space is going to be removed by the tokenizer anyway. So we can just like put it like that. I think that's fine. So because of that, the first token is going to be name. Yeah, as you can see, here's the name, and these are two separate tokens, which is fine. So that's pretty cool. Okay. So now we don't really know why it failed. It failed because it reached the to-do, right? It reached this place. Right, so let's actually do the following thing. Invalid token starts with, right, and we can do the following thing. Start equal to self content 0. So we'll know what we're dealing with. So it starts with, that's very weird. So how can we take into account this kind of stuff? I think I know. If we encounter like weird symbols and shit, maybe we're gonna treat it as a separate token, right? So here we're gonna do the following thing. Okay, the token is basically this one, right? Then we reslice this entire thing from 1 up until here, and then we just return this entire token. So at the end here we don't have to return anything. And that kind of takes into account all of these tokens, right? So like weird things. Let's see how bad is it gonna go. Yeah, so this is actually pretty good, except for the numbers, right? The numbers are not tokenized properly. And let's try to tokenize them. So this is gonna be content. If this is a numeric, if this is alphabetic, so this must be numeric, we're gonna be doing the following thing. While it is numeric, we're gonna be doing it like that. And oh, numbers didn't really work, but I suppose those were like a really separate numbers then. Can we have like numbers that have more characters? While it is numeric, it is numeric. I don't know. I guess it's fine. So that's cool. So, and again, oh, yeah, here we go. So I was looking for number like this, like for stuff and whatnot. 2. So yeah. And what's interesting is that you can see like a garbage like this. But if this garbage is going to be very frequent in all of the documents, the TF-IDF formula is going to basically filter that off. So we don't really have to worry about like having this sort of random garbage in the things, right? Because it's not going to really affect too much. And if anything, maybe in the future we can simply have some sort of like a list of stop words, just like ignore these kind of tokens and whatnot. Probably for that, like this is more than enough to tokenize things. Maybe another thing I would like to do is to bring all of those things to uppercase, if you know what I mean. Right, so map, so X uppercase, is that what it's called? I think uppercase. To uppercase, let me take a look. Oh yeah, I remember there's something weird about to uppercase. It like removes returns an iterator. Returns an iterator that yields the uppercase mapping of characters as one or more characters, so it actually can have more characters. I think there was a way to have like a more classical to ASCII uppercase. Yeah, I vaguely remember this kind of stuff. Some things I remember in Rust, some things I don't. I just like kind of interesting. And this one returns a character. Okay, so to ASCII uppercase, and yeah, so this is one of the things that I may want to do. Right, and because of that, like words with a different case are going to be considered the same tokens, and maybe it's going to be like easier to handle. We'll see. Right, but if we're going to be doing uppercase, we'll probably have to do that on a level of a tokenizer, right? Because the tokenizer yields those things. And that means that we probably need to return a string in here, but yeah, we'll see. We'll see. So I have the idea. So we can compress a couple of things in here. As you can see, we actually repeat this kind of part 3 times. And this part, it's only parameterized by n. So it basically tells you how many characters you want to chop off from the content. Right. Chop off from the content. Chop, and we're gonna accept the mutable self, right, and use size. And in here, we're gonna return the slice of the character, right. And we can move this entire thing in here. So, but since we always return something, we don't have to wrap it in sum. And now, in all of these places, we can just do, I think, return sum self chop n, right? So the first thing we do, we compute the n, right? We compute the n, and then we chop the, like this amount of characters. We can do the same thing in here, sum self chop n. And here we know that we want to chop a single one, so we can always do self chop 1. Okay, so that works. Another interesting thing is that we definitely have a repetition here, but the problem is that we have different predicates in here. Right, so we can try to factor that out as well, but calling it something like chop while, right? So we're gonna accept self, and here we'll have to accept the predicate p, and this thing is going to return the slice. But the question is how we define p. So we can try to define the same way as defined in take while, right? Because there's like fn, fn once, fn mute. I don't really know the difference between them, so I'm gonna just follow whatever convention in this in take while. I know that mute, that means it can modify its environment or something like that, but I don't remember implications. Right, so we can use fn mute, and it takes it by a reference. Do we really want to take it by a reference? We can take it by a reference, right? So, but yeah, we'll see. Okay, so this thing is going to be a fn mute. It's going to take the character by a reference, and it's going to return a boolean. Right, so, and in here we can simply just move this entire thing. Right, and yeah, return self chop n. So instead of like calling this thing, we're going to be calling predicate. All right, predicate by a reference, because it's supposed to accept the reference. And there we go. So now we can have a customizable predicate. So essentially here we take until it's numeric. So that means we can chop while x is numeric, and we can remove this entire thing now, right? So that compresses it even more, right? And we can do the same thing in here. So this is alphanumeric. So chop while x is alphanumeric. We can remove this entire stuff. So the entire logic of Tokenizer is now this, and we have two very powerful things that are reusable, right? So we can chop while a character satisfies certain predicate, or we can chop like exact amount of things, right? So, and all of that is just like factored out, right? So now it's super convenient. If we want to chop like specific prefixes, we can quite easily do that, right? So we can introduce that functionality, but I don't feel like we need that functionality right now. So whatever we have here is already enough, right? It's more than enough. Okay, so let's actually go through this entire stuff. P not found, this is because it has to be generic, right? Predicate, help consider it has to be mutable, so it wants it to be mutable in here, sure. Cool. So let's say that this is the tokenizer, right? So this is the tokenizer that we're dealing with. Let's try to build the frequency table, right? So for that specific document, term frequency. Let's call it TF, right? So this is going to be hash map we accept the string, right? So since we're, you know, bringing it to uppercase, and then we're going to do the size. Right. So let's create this thing. And of course, this thing has to be mutable. So the first thing we want to do, we probably want to TF. This is because TF is a troll face emoji. Yeah. We want to check if the term, if the token is already in the table, in the TF table, right? So let's take this entire stuff and let's call it term. Right, this is a term. TF get mutable, because we're going to be modifying it. If it exists, we're going to just increment it by 1. Right, so token term. If let sum count, count plus 1. Otherwise we're going to be probably just inserting. This one is interesting, right? Yeah, I think we're gonna be like moving it inside, right? I think it's totally fine. So since the string was created in here, and at the end of this loop, it's gonna be either destroyed or moved inside of the hash map. So that's totally fine. So this one is gonna be 1. All right. So now let's go ahead and maybe print those things. Right, so hash map, does it have like something like items? Oh, maybe you can just iterate it, right? So you can do something like term and frequency. Right. So since it's a frequency, maybe I should also call it frequency, right? So it's a term frequency, this is a term frequency. In TF, let's actually can call TF in TF, right? So we're iterating this entire thing, and then we can say, okay, so this is how this specific term, how often it, you know, occurs in the document specifically. Okay, so let me see. So frequency, binary assignment is mutable. I have to dereference it first. Maybe I don't need that stuff anymore. Exit is not, okay, sure. Semicolon, what else? Okay, so these are the terms. This is how frequently they basically occur. But it would be nice to actually kind of sort them by how frequent they are, if you know what I mean, right? So it would be kind of nice to do that. We can try to basically collect all of that into a vector, right? And sort that vector, you know, by the frequency, right? By the frequency. But here we're iterating by reference, right? So we're not really moving out the elements from the hash table, right? So we can actually kind of do that. I don't think it's that bad, right? So we'll call it stats, and there we go. Here we have a vector of stats. Then we can just sort it by sort by. Oh, you can sort by key. That's actually pretty cool. Right, so how do you provide the key? You provide through the function. Oh, basically, you take the element and you extract a key out of the element, telling by what you have to compare things. Okay, that's cool. Sort by. So we accept in here, and we have a term and frequency. We don't care about the term, we only care about the frequency, and since it's a reference, I just do it like that. Right, so... And then, after we sorted all of that, I probably want to reverse this entire thing. Can I reverse? Okay, so you can reverse the slice. And if the slice, I suppose it has to be mutable. Yeah, okay, so that means I can do stats, reverse. Cool. And now we can do something interesting, I suppose. We can take the stats, but we can also take, like, top 10. Let's take top 10, right? So we're not interested in all of the tokens, we're only interested in top 10. So sort by takes 2 arguments. Sort by key. That's right. Let's go sort by key. This has to be mutable, sure. I don't mind that. Okay, look at that. These are top 10 tokens within the document. Isn't that cool? So these are top 10, which actually kind of makes sense with dots. It does make sense, right? So dots are very frequent. And also vertex is also very frequent, right? So let's actually take 100. So a lot of words like happen there like uniquely. Must errors, so they happen like one time. You know what I want to do? I actually want to iterate through all of the documents within the directory and do this process on them, right? So essentially I can do println and say file path, and I can pad this thing with like 4 spaces, so we can just separate the name from the file name. File path is not called file path. Okay, so I should have actually do it like this. So this is the file path. File path, boom, boom, boom. Okay, so as you can see, here is the file path, and here is the top 10 tokens. We can now put that in a loop, right? So here we have a directory, right? We have a directory. We read the directory, and here we have a file path. Right, so we can take this entire stuff and move it inside of that loop, right? Just move it inside of that loop and iterate through all of the files, and for each file compute the stuff, right? So there we go. This is gonna work. So fs is not available, and this is because I removed it. Yeah, file path. This one is a little bit weird, but we can easily work around that by doing that. File path. So has it move occurs? Okay, so the file path was moved. This is because we want to actually take a pointer in here, and there we go. So we're going through all the documents and we're analyzing all of them, right? And we're seeing how frequently certain words occur. It's actually kind of cool. GL get active uniform block. Uniform is actually one of the frequently used. Uniform and block. Uniform and block. So we pick the random. Sample parameter. Texture GL. So we know that this thing is probably related to texture. We can already see what these things are related to. So this thing is related to texture. This thing is related to frame buffers. This thing is related to samplers. Well, yeah. Uniforms. What's funny is that get active uniform name, the most like frequent thing here is program, but maybe down there there's also uniform and whatnot. So yeah, this is cool. Isn't that cool? It's actually pretty cool. Buffer subdata of buffer, yeah, length. Damn, that's so cool. Right, so for instance we have this thing as like 10, but we can configure that top n, right? And we can say, okay, top n is going to be 20. Let's actually do 20 here. So now we can see more terms. We can see more terms. That's pretty cool. So now, once we have this frequency, so maybe we could actually do type TF hash map string to use size, right? So this is a TF. TF, and we can simply just replace this thing with TF. Because now I want to have the document index, right? So TF, I don't know how to call that. Right, so I want to have a name for a thing that maps a path, right, certain path, maybe even path buffer, to TF for that specific document, right? So if this is the term frequency, let's call term term freq. So a mapping from a document to a term frequency for that document. How would you call that thing? I have no idea. That's kind of difficult. Index? Maybe index. Global index. Term freak index. Yeah, boy. Term freak index. Okay. Term freak. And in here we can have TF index, which is term freak index. Right. And essentially now, as we iterate through all of the files, right, we can add this thing to the global index, right? So we can do it. TF index insert file path, and file path, as far as I know, is a path buffer. So we can just move it inside of the TF index, right? We move it inside, and we just move TF inside of it as well. So we're not going to print anything, right? We're going to just try to build the entire thing. And we can try to iterate through all of that stuff. Okay, so path TF in TF index. We can do println. Has count unique tokens. That's a pretty good thing. And we can do TF length. So the amount of entries with the term frequency is the amount of unique tokens you have in this thing. And thus we're going to demonstrate that we managed to parse all of the documents. What's funny is that it's going to take some time. We already demonstrated that it's rather slow. So maybe one of the things we have to do in here is print the progress, right? Indexing file path, right? Yeah, let's put it like this. So it also would be nice to put triple dot in here. Okay. TF-len count. What else do we have? We have a path buffer. Path buffer is located to where? std path. Yep. Path buffer. So the difference between path and path buffer is similar to difference between str and string, if I'm not mistaken. Right. So path buffer owns the data that represents the path, and path is just like a view on that data, right? Because of that, in TF index, in this specific thing, we own it, right? Because it's gonna be like self-contained in there, right? So let me see. TF index is not mutable, but it probably has to be mutable. Okay, so and it's taking some time to index all that, right? So we're indexing things. We're indexing things. It's pretty cool. Alrighty. And it didn't print. Okay, so at the end, after it finished indexing, it also printed the amount of unique tokens within each individual thing. So this is where it finished indexing, and this is where we said, okay, so this is basically the state of this entire shite. It would be kind of cool to just dump the hash map somewhere. It would be kind of cool to just dump it somewhere. Maybe in the form of a JSON or whatnot. Because reparsing all of that is kind of a pain in the ass every time. It would be nice to just dump it. Right. It would be nice to just dump it. Right, so let me see. I have no idea. I didn't think about that. Okay, Rust. Dump hash map as JSON. I swear to God, if it's gonna suggest me to, yeah. Okay. Shit ton of dependencies on top of dependencies on top of dependencies. Framework of frameworks. Serializer of serializer. Framework of serializer. Serializer of frameworks. Pain. Literally pain. I freaking know that the restitutions are gonna debate me into that madness. I knew that they're gonna do that. I knew that they're gonna do that. I'm not gonna be playing by their games. Fuck that. But Zozin, don't you want 1 terabyte dependency folder? It's kind of tempting, not gonna lie. It's kind of tempting. Anyway, so maybe we can store that shite in, I don't know, in a custom format or something. So, Rust, generate JSON. Though I have an idea. Okay, so here's the JSON, right? So surrogate JSON, whatever the fuck it is. Let's take a look at the dependencies. So development dependencies. Raw values. So it is like the lower level stuff, right? So it is the low level stuff. Oh yeah, but I mean it's dev dependencies, but the actual dependencies here are on this thing, which is okay. All right, let's try the sorted JSON thing. This is gonna be. Imagine having a separate package for I to A for a function that converts integer to a string or whatever the fuck it is. I assume that this is from C. Right. Let's see. I'm gonna regret that shit. Well, of course you need to update the criteria. Okay, so we added that shit. So apparently I already had that somewhere. Okay, let me remove that. And let's try to build this thing. Oh yeah, so it's not downloading until you try to build that. Okay, so it wasn't that slow, so maybe I'm gonna be okay with that. So let's open the documentation. So I want to build documentation for Surdy and Surdy. Do I even pronounce that correctly? Do I even care if I pronounce that correctly? I don't. Okay. So checking Surdy JSON. Imagine building documentation. My God. So JSON. Okay, can I do something like toString? toString, okay, that's cool. But if I want to build this stuff out of the... What if I want to serialize? Okay, so I can try to serialize that. Serializing a structure. Hash map. Any type that implements serialize a trait can be serialized this way. Ooh. Maybe... So that means I can just like use this stuff. Right. I can just put this stuff in here, right? Then I can simply take this. So this is also result. TF index to string, but then I want to save that shite. Does it have something like save directly to a file? Save directly to a file. So let's take a look at the list of available thing. Surdy JSON to right. Aha. You provide the writer and you provide the serializable value. So that means we can do the following thing. We can open a file, we can create, let's call it something like index path. Right, so this is the index path, index.json, println, saving, saving index path. Okay, so we create the file, of course. We create the file, index file. And then we want to do serde.json to writer index file. So in the writer is just like this. So I suppose it's you want to move it inside. Yeah, I guess that makes sense. You just move it inside, and then we provide the TF index, right? And this thing returns the result, but the result is what? A result is this thing. Okay, expect serde works fine, because the main returns a different kind of error. I'm not in the mood of actually adapting errors around and stuff like that, so I'm gonna just do it like this. Maybe you can just like a map error and whatnot, and the actual error could be a string. I couldn't do that, sorry. So use of undeclared crate, but do I really need that? Is it really that important? I don't think. Okay, so it was not important. So, okay, that's cool. Oh, I mean, I built the documentation instead of the program, so maybe it is important. Okay, so it's not failing or anything. Let's try to run this. Okay, so we're indexing thing. We're indexing thing. And then we're going to be saving the JSON, hopefully. So, and definitely every time I want to do search, I don't want to do this process over and over again. That's for sure. That's why I need to be able to save that to the JSON. And we've got a JSON, which is, I mean, 640 kilobytes should be enough for everyone, but we can't even fit index into that. So let's open the index JSON. I can't open it in Emacs. Emacs actually dies because, okay, there we go. So can you see this shit? But this is the index built out of the stuff, which is kind of cool, isn't it? I think it's pretty freaking cool. Bitrate is actually pretty bad. But one of the things we can do, actually, we can do JQ index JSON, index pretty JSON. I don't remember. Can you just do cut? Yeah. What did it say? It says something, some bullshit. I forgot how to use JQ. I suppose you just do that. JQ pretty print. I don't remember. How do you do that? Pretty. Yeah. Okay. Pretty print. Dot. Oh yeah. You cut it and what I mean. It's not an answer. Yeah. Jesus Christ. Imagine the interface so unintuitive that you have to Google this kind of stuff. Okay, so now I can do index pretty JSON, and it's 1 megabyte, but I mean it's worth it. There we go. So here's the index. So this is for the first one, this is for the another one, and so on and so forth. Okay, that's pretty cool. So we have 63,000, almost 64,000 lines of code. Right. So that's the index. Now we need to be able to read this entire shit, right? So because we want to, you know, take the index and just do something with it, right? So let me see how we're gonna be doing all of that. So I'm gonna comment out, sort of comment out the entry point, right? So this is gonna be fn main results. So the question is, in serde, do we have from reader? Yeah, we do have from reader, so this is sort of like symmetrical thing. So that means I can do let file path, let's call it index file path, which is index.json, right? Open index path, index file, like so. And when I do from, it literally returns the result in here. Okay, so that's fine. So the JSON from reader. And I have to specify the deserialized owned. I suppose I have to like say the actual type. So TF-index, I have to say that it's a term frec index, right? So that's what I have to say. And here I'm going to wrap in. So hoping that the compiler is going to infer the type for this thing correctly. And also I'm moving the reader there. So index file. So and after that, we're going to be doing the following thing. I want to actually do something like reading index path index file, right? Because maybe it's going to take some time. We'll see how fast it is. And then let's just iterate, all right? So maybe not. We can print something like very short. Index path contains count files, right? So an account is basically TF index length. There we go. So in here we'll probably want to do expect because it's a different kind of error. What are we gonna third does not fail. Right. Okay. So let's do the cargo build just to ensure that everything's fine. So at the end we have to say okay. And it builds, believe it or not. So now if we do run, no file or directory. For what precisely? Oh, this is because I'm not in the right place. Okay, so that's faster than what we had. Look at that. That's faster than reindexing everything. It's still kind of slow, and maybe this is because of the not like debug build. So let's actually do release one. Oh, it's gonna rebuild everything for release one. So BeanLab, thank you so much for the Twitch Prime. Thank you. With the message hello to you too. Hello. Building I to A. That's a very big framework that you need to build. Okay, so now if I just try to run it, still kind of slow. But anyway, so yeah. That's pretty cool. So we already have all of the like building blocks to build some sort of a system. So the actual thing that we need to do in here is to, get the prompt from the user, and tokenize it, and then compute the ranking for all of the documents. So here's an idea. So how we're going to do the search? We take the prompt from the user, we tokenize it the same way we tokenize all of the documents, right? It's quite important to have the same tokens and stuff like that. Then for each token, right, for each document, we compute the TF-IDF of that token, then TF-IDF of another token, and another, and we have a bunch of TF-IDFs for the prompt for that specific document. We sum them up. And this is the ranking of that document for that specific prompt. We repeat that for each individual document. And we have rankings for each individual document for that specific prompt that you provided. And then we just sort the documents according to that ranking. And we give it like top 10, top N, right? And then you pick the document that you're interested in. So that's the idea of how we can be querying all of that stuff, right? So it would be kind of nice to maybe have some sort of subcommands in here, right? So because you need to be able to do two things, right? You want to be able to index a folder, right? You want to index the folder. And then once you create the index file, you want to be able to, given the index file, search with a certain prompt. So you have two subcommands like index and search, right? So, and this is probably something that I want to do. But unfortunately, I'm already streaming for 2 hours. So I don't really want to go over 2 hours. So I think I'm going to stop the development here and we're going to continue doing this thing next time. All right. Does anyone have any questions before I go? Yeah, I'm sorry. Like if I go over 2 hours, I get really burned out and it's not going to go well. Right. So one of the things I'm going to do, I can give you the source code. Okay, so right before I go, I can just give you the source code and yes. I'm not going to include docs.gl. I'm not going to include docs.gl. You're supposed to, you know, clone it yourself. Right. So this is that, and no. Ready, set, go. Do we have a readme? Did it generate readme? Didn't generate readme. Right, so how did I call the project? I forgot how. I'm Cirrust. I called the project Cirrust. Okay. Bruv. Cirrust. So the idea is that this tool should work universally on any folder with XMLs. That's kind of the idea, right? So, and maybe in the future, right, as already said, we're going to support several, you know, several formats. And we also need to implement so it actually traverses recursively. So that would be cool. Okay. Search engine, local search engine. Yeah. Local search engine. That's how I'm gonna call it. Nothing much to say. So what's the license? License. It's gonna be under MIT. Under MIT. Add origin Cirrust. I also wanted to include the license, so I'm going to quickly amend that. So now license is available, and I'm going to push that right into the repo. So let's refresh. So the source code for this thing must be available in here. I'm going to copy paste it in the chat. And for people who may be watching on YouTube, it's going to be available in here. Source code. This is not source code. This is a source code. It's not even source code. All right. Isn't it POG? So maybe off screen I'm going to clean it up a little bit. So maybe introduce some subcommands and whatnot. And then on the next stream, we're going to try to actually implement the search. So Mr. Todging, I know it's early in development to tell, but do you plan to carry this project on? I'll see. I'll try to use it locally and see if it has a potential for me. And if it does, I'm going to carry on with that. So yeah, I don't know yet. We'll see. Alrighty. Iceleo, thank you so much for the sub with the message. Thanks, Zozy, for not being irresponsible and writing C in 2023. Yeah. Alright, so that's it for today, boys and girls. Thanks everyone who's watching me right now. I really appreciate that. Have a good one, and I see you all on the next Azuzian session.